Hello everybody, today we're going to be doing Cambridge IGCSE Chemistry Paper 4-1 May-June 2023. Let's proceed to question number 1. Some simple equations and word equations A to J are shown. Use the equations to answer the questions that follow. Each equation may be used once, more than once, or not at all. Give the letter A to J for the equation that represents part A, a neutralization reaction. Now when we go through the options, as we can see, our answer would be B, and that's because we can see H plus is an acidic ion and OH minus is a basic ion, and they form a neutral compound which is H2O, also known as water. So our answer for part A would be option B. B, a precipitation reaction. Going through the list, our answer would be option A, and that's because FeOH3 forms a red-brown precipitate when iron reacts with hydroxide ion. So our answer would be option A. The formation of an ester. Now that's pretty clear that our answer is H, and that's because we can see that it's a word equation and ethyl ethanoate is an ester. So our answer for C would be option H. Photosynthesis. Our answer for that would be J. So part D, our answer is option J. Fermentation. Now fermentation is the process when ethanol is formed after the reaction of ethene with steam, and as we can see, that is option E. So our answer for part E is option E. Cracking. Our answer for that is D, and it's quite clear. As you can see, C12H26 is getting cracked into C8H18 plus C4H8. So our answer for part F is option D. Moving forward to question number 2, we have the symbols of the elements in period 2 of the periodic table are shown. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that part 1 makes approximately 78% of clean dry air. That would be N, also known as nitrogen. Contains atoms with only 3 electrons in the outer shell. You can get that answer from the periodic table. The answer is B, boron. Contains atoms with only 9 protons. That's again, the answer comes from the periodic table. Fluorine exists as graphite. Graphite forms from carbon, so our answer for part 4 is C. 5 is an alkali metal. That's Li. Lithium. 6 only has an oxidation number of 0. That means it does not gain or lose electrons, so that would be neon, which is part of group A. B, boron has 2 isotopes. State the meanings of the term isotopes. They're basically asking you for the definition of isotopes, which is atoms of the same element that have the same number number of protons but different number of neutrons. Or you could also say that have the same proton number but different nucleon number. Table 2.1 shows the relative masses and the percentage abundances of the 2 isotopes of boron. Calculate the relative atomic mass of boron to 1 decimal place. Alright, so we have the calculations part here. That would be our A. We would basically multiply the relative mass with the percentage abundance, add those both and divide that by 100, and we'll get our answer. So that's 10 multiplied by 20 plus 11 multiplied by 80, bracket close, the whole divided by 100, and our answer would be 10.8. Moving to question number 3. The question is about ionic and covalent compounds. Sodium reacts with oxygen to form the ionic compound sodium oxide. The electronic configurations of an atom of sodium and an atom of oxygen are shown in figure 3.1. Ions are formed by the transfer of electrons from sodium atoms to oxygen atoms. Complete the dot and cross diagram in figure 3.2 to show the electronic configuration of one sodium ion and one oxide ion. Show the charges on the ions. Alright, so as we can see here, uh, this is the sodium ion, this is the oxide ion. Sodium is located in the first group of the periodic table. That means it has one electron in its outermost shell, and they are asking for the outermost shell. Yeah, so sodium loses its only electron in its outermost shell and gains the electronic configuration of group 8 atoms. So it basically, sodium has 11 electrons in total, and after it loses one electron it forms uh, sodium ion with only 10 electrons, but the electronic configuration similar to group 8 atoms. So we'll have this. I'm sure you guys can understand. And about the oxygen, oxygen gains one electron, actually two electrons. Oxygen gains two electrons from the sodium ion. So oxygen initially has 6 electrons in its outermost shell because it's in group 6, and once the sodium and oxygen react, oxygen gains sodium's electrons. Now, the charges. As we know, oxygen needs 2 electrons and we only have one sodium here, right? So basically, in the formula, if we look at the formula is Na2O. So we have two sodium ions. However, we will only write the charge of one sodium ion here. So that would be, either we could write minus or -1. I prefer to write -1. And when we come to oxygen, oxygen gains 2 electrons, so we will write -2. Alright, part 2, write the formula of sodium oxide. Now again, that's Na2O, as I said in the last part. That's because sodium has one electron in its outermost shell and oxygen needs 2 electrons to reach the electronic configuration of group 8 atoms. Once you have two sodiums giving one electron to oxygen, it would have 8 electrons in its outermost shell, and both of the sodiums would also have 8 electrons in its outermost shell. B. Carbon dioxide. CO2 is a covalent compound. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of carbon dioxide. Alright, let's zoom in a little bit. So when we talk about oxygen, it has 6 electrons in its outermost shell. Let's draw the first 4 in both of the oxygens. Right. Carbon has 4 electrons in its outermost shell, and it forms double bonds with both of the oxygens, so it would share 2 with one of them. So that would give them both the electronic configuration of group 8 atoms. There you go. Moving forward, the melting points of sodium oxide and carbon dioxide are shown in table 3.1. Explain in terms of bonding why sodium has a high melting point. Alright, as we know, sodium oxide is an ionic compound. Ionic compounds usually tend to have a higher melting and boiling point compared to covalent compounds. So our reason is sodium oxide is an ionic compound which contains high electrostatic force of attraction between two oppositely charged ions, which is very hard to come over. Hence, it has a high melting point. Alright everybody, as you can see here, I added an additional line, and this one aligns with the marking scheme more, so it would be better to write two oppositely charged ions which require high amount of energy to be overcome. That describes the higher melting point even better than the previous lines. Alright, carbon dioxide has a low melting point. State the general term for the weak forces that cause carbon dioxide to have a low melting point. That is intermolecular forces. Alright, moving to question number 4 now. Oxygen is produced by the decomposition of aqueous hydrogen peroxide, manganese 4 oxide, MnO2 is a catalyst for this reaction. State the meaning of the term catalyst. A catalyst is a substance that is used to speed up a chemical reaction and remains unchanged at the end of the reaction. Part B. A student adds powdered manganese 4 oxide to aqueous hydrogen peroxide in a conical flask as shown. The mass of the conical flask and its contents is measured at regular time intervals. The mass decreases as time increases. State by the mass of the conical flask and its contents decrease as time increases. Alright, oxygen is produced, right? So the answer to that would be because oxygen escapes through the flask, so the mass decreases. Alright, moving forward. B part 2. The rate of reaction is highest at the start of the reaction. The rate decreases and eventually becomes 0. Explain why the rate of reaction is highest at the start of the reaction. That's because the hydrogen peroxide is at the highest concentration level. Now the explanation to part 2 would be it's because the rate of reaction is proportional to the concentration of reactants, which is the greatest at the beginning of the reaction. Part 3. Explain why the rate of reaction eventually becomes 0. Now the answer to that would be it's because all the hydrogen peroxide has been used up. Moving to the next part, the experiment is repeated at an increased temperature. All other conditions stay the same. Explain in terms of collision theory why the rate of reaction is higher at an increased temperature. Right, so the particles gain more kinetic energy once the temperature is raised. Hence, they move faster and collide more frequently. More particles have sufficient energy. Sufficient basically means energy needed to perform a reaction, or you could say energy that's equivalent to the activation energy. Reaction, right? More particles have sufficient energy. That's our answer. Part D. The equation for the decomposition of aqueous hydrogen peroxide is shown. Calculate the number of moles of H2O2 used. As we know, the formula to find the concentration here would be concentration multiplied by volume. However, as we can see, the volume is in centimeter cube, and we would need to change that into decimeter cube. So we would multiply 50 by 0.2 and divide that whole by 1000, and we would get 0.01. Determine the number of moles of O2 produced. Alright, so we will use the ratio method, and as we can see, the ratio is 2 to 1, so that means the number of moles of O2 would be half the moles of hydrogen peroxide. So the half of 0.01 divided by 2, and that becomes 0.005. Calculate the mass of O2 produced. Alright, so the formula to calculate the mass would be mass is equals to mole into mR. How would we get the mR? As we know, the mass number of oxygen is 16. So we would multiply that by 2 since that's O2, and we would get 32. So we would do mass is equals to moles, which we got 0.005 in the last part, multiplied by 32, and our answer should be 0.16 grams. Moving to the next part, state the effect on the mass of oxygen produced if the mass of powdered manganese 4 oxide catalyst is increased. Well, it has no effect. Now the explanation for that is because the amount of O2 only depends on the mass of the reactants and not the catalyst. Oxygen can also be produced by decomposition of mercury 2 oxide HgO. The only products of this decomposition reaction are mercury and oxygen. Write a symbol equation for this decomposition. We basically just have to write down a balanced equation, and let me just do that. Alright, and that will be Hg plus O2, and now we just have to balance it. That would be 2 and 2. Next question. Question number 5. This question is about electricity and chemical reactions. The electrolysis of concentrated aqueous potassium bromide using graphite electrode forms hydrogen at the cathode, bromine at the anode. The electrolyte becomes aqueous potassium hydroxide. State what is meant by the term electrolysis. Electrolysis is the breakdown of ionic compounds by passing electricity through them in molten or aqueous form. State why graphite is suitable for use as an electrode. It is inert. Write a half ionic equation for the formation of hydrogen at the cathode. That is basically 2H, and we would have a just a minute, that's plus sign on the top. Yep, just like that, plus 2E minus, we'll write that down just in a minute, and it forms the hydrogen gas. So basically it's just hydrogen ion forming the hydrogen gas after a reaction at the cathode. Alright, name the type of particle responsible for the transfer of charge in the conducting of wires. Electron. Name the type of particle responsible for the transfer of charge in aqueous potassium bromide. That's basically the liquid part, and that would be ions. Part 6. State the names of the products formed when electricity is passed through dilute aqueous potassium bromide using graphite electrodes. At the anode, we would have oxygen form. That's because Whenever we have electrolysis of a dilute compound, we would always have oxygen forming at the anode. However, if we have a concentrated compound, we would have group 7 ions forming only if one is involved. At the cathode, we would have hydrogen forming because there is no metal here that's below than hydrogen in the reactivity series. Part B. Bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis. Name the aluminium compound in purified bauxite. That's aluminium oxide. State 2 reasons why cryolite is used in this electrolysis: to lower the melting point. The second point would be to increase the electrical conductivity. Yep. Alright, moving to the next part. Explain why carbon anode has to be replaced regularly. That's because the oxygen forming at the anode reacts with carbon to form carbon dioxide. Hydrogen oxygen fuel cells can be used to produce electricity in vehicles. Write down the simple equation for the overall reaction in a hydrogen oxygen fuel cell. Now that's a very basic equation. 2H2 plus O2 gives us H2O. Well, actually 2H2O if we have to balance it. Oh, alright. State one disadvantage of using hydrogen oxygen fuel cells instead of petrol in vehicle engines. It's more efficient. That's just a part that you need to memorize. Moving to question number 6. Alright, this question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid H2SO4 by contact process. The process involves 4 stages: stage 1, stage 2, and stage 3 and 4. In stage 1, iron pyrites FeS2 can be used instead of molten sulfur. The iron pyrites is heated strongly in air. Balance the equation for the reaction occurring when iron pyrites reacts with oxygen in the air. Now to balance the equation, you have to be very careful and you have to go through all the calculations part. Alright, let's check if that is correct. For iron, 4 irons, iron atoms, 8 sulfur atoms, yeah, that's right, and 22 oxygen atoms. Yep, that's correct. Name Fe2O3, include the oxidation number of iron. That is iron 3 oxide. The equation for stage 2 is shown. The forward reaction is exothermic. The reaction is carried out at a temperature of 450 degrees Celsius and a pressure of 2 atm. Using explanations that do not involve cost, explain why temperature greater than 450 is not used. Well, that's because if the temperature is raised, the reaction would shift backwards and produce more of oxygen. So we need to keep the temperature steady so it produces more of SO3. So we will write the yield of SO3 produced is less. Coming to part 2, explain why pressure lower than 2 atm is not used. That's because when you increase the pressure, the side of the reaction which has less molecules gets the advantage. However, if you decrease the pressure, the equilibrium, by advantage I meant the equilibrium shifts, but when you decrease the pressure, the equilibrium shifts to the side which has more molecules. So that's why we cannot use a pressure that's too less. So we will write the same answer again. The yield of SO yield sorry the yield of SO3 produced on a lower pressure is less. Coming to part C, when sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the symbol equation for this reaction. Alright, so it's sulfuric acid reacting with ammonia. That would be H2SO4 plus NH3, and it gives us, that would be NH4, and due to the cross multiplication of the charges, we would have 2 here outside of the bracket, SO4, and this would be 2 to balance out the equation. Yep, alright. Going to the next part, the lead 2 sulfate is an insoluble salt. Lead 2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead 2 sulfate. The answer to that is lead 2 nitrate. Now the explanation to that is because the lead in the lead 2 nitrate replaces ammonium and forms lead 2 sulfate, while the ammonium in the ammonium sulfate reacts with the nitrate to form ammonium nitrate. Add 2 nitrate. Alright, write an ionic equation for this precipitation reaction. Include state symbols. There we have it. That's the equation, ionic equation of the reaction. Part 3. The precipitate lead 2 sulfate forms in an aqueous solution. Describe how pure lead 2 sulfate can be obtained from the mixture. So now we have to write the description of the process here. So separate the solid lead 2 sulfate from the mixture using filtration, then wash the residue using distilled water, and then heat it on a low flame to let it dry. That's it. This question is about organic compounds. Butane reacts with chlorine in a photochemical reaction. State the meaning of the term photochemical. Reaction which needs ultraviolet light, or uses would be better. An organic compound with the formula C4H9Cl is formed when one molecule of butane reacts with one molecule of chlorine. Draw the displaced formula of 2 possible structural isomers with the formula C4H9Cl formed in this reaction. Alright, so there we go. That is the possible formulae of 2 structural isomers. We basically just changed the chlorine atom from the first carbon to the second carbon, right? Part B. The structure of compound A is shown in figure 7.1. Deduce the molecular formula of compound A. Basically, we would have to count in how many number of the types of atoms are here. So we have 1, 2, 3, 4. Let me check. Yes, 4 carbons. So that would be C4. All right, C4, and 1, 2, 3 oxygen. But let's check the hydrogens first. 1, 2, 3, 4, and 6. So H6O3. There you go. There are three functional groups in compound A. Name the homologous series of compounds that contain the following first functional groups. Carbon double bond, that's an alkene. OH is the alcohol group. COH is carboxylic acid. Alright. State what is observed when A is added to aqueous bromine. A. Alright. It turns colorless. So it turns colorless because the alkene group reacts and this double bond between the C breaks and the C bonds with bromine. As bromine is used up, brown color due to it disappears. Aqueous sodium carbonate. We just have fizzing or effervescence. And that's because Na2CO3 is a base and it reacts with acid group of compound A which forms CO2 and it causes effervescence. You may like to call it that way. Compound A can be used as a single monomer to produce two different polymers. Draw one repeat unit of the additional polymer formed from compound A. Now since it's asking for a repeat unit, that means it has to be the same as this one. So you would draw the same as this one. However, this time you will not draw double bond between the carbons because the double bond between the carbon atoms would break, so it could form single bonds with the monomers. Now there you go. That's one repeat unit. Compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed from a dicarboxylic acid and a diol. That would be a polyester. Alright everybody, thank you for watching. I hope you all have a great day.